As coding projects increase in size, it helps to organize logic, functions, and classes into separate files. I'm going to show you an example about how to organize code across different files in a project that would be composed of 3 files: main.cpp, factorial.cpp, and print.cpp. First, I'm going to create the main.cpp file. So it's going to be hash include iostream, hash include string, using namespace std. I'm going to define a function int factorial of int and void print of std string. Then we have our main function. I'm going to initialize 2 variables, int num equals 7 and int num factorial is going to call the function factorial num. And then I'd like to print out the results. So string to print equals factorial of plus 2 string of num plus is plus 2 string of num factorial. So I'm going to combine all this information into a string, so converting numbers into string and then concatenating the string together. Then I'm going to call the print function to print the string to print. Okay, so what you notice here that I've declared 2 functions here, int factorial of int and void print of string, and these are not defined in main.cpp, they'll be defined in a separate file. So what I'm going to do is define factorial.cpp. Remove this because I don't think we need it. I'm going to add a file, call it factorial.cpp. It's empty, but I'm going to define our factorial function, hash iostream, using namespace std. And our factorial function we saw earlier when we covered recursion basically receives a value n. If n is equal to 1, it just returns 1. Otherwise, it executes n times factorial of n minus 1. So it's calling itself again with n minus 1, and that logic recurs. So that's our factorial function. Now I'm going to define the print function. So I'm going to create a new file, call it print.cpp, empty. So I'm just going to have a very simple print statement. I'm going to import iostream and string and define my print function. So it returns nothing, so it's void print of string of string. So some string variable will be passed and that will just be printed right away. So that's our print function. If I go back to main and I click run, it should run fine. So you can imagine if we have a very complex code, we would have our main function, but then we potentially could have a lot of functions that we're calling from other files. And this can take up a lot of space, it can clutter things. So what we could do is create our own header file. And the header file would contain information on the functions that should be imported. I'm going to create a header file. It's going to be called function.h. And if we're defining a header file, we have to use the .h. But the first thing I'm going to put into my header file is a hash if n def function underscore h. So what this is anytime you see this hash symbol, it's a macro to the compiler, or in other words, it's a signal to the compiler that at compile time it's going to have to substitute the statement for something else. So we have this if n def, which means that if function of h hasn't already been defined, then define function of h. So we're going to define the rest of this code as function underscore h. And it's going to be the two functions we had declared in our main file, int factorial of int and void print of std string. And I'm going to end this if logic wrapper around our function.h. So at compile time, anytime there's a hash include function.h, it's going to be substituted by whatever this captures, and this captures these two lines. So if we go back to our main.cpp, we can now, instead of having this forward declaration of these two functions, we can do our hash include function.h. And so at compile time, our compiler is going to go and substitute this line, because hash include means substitute this expression for whatever function.h was defined to be. It comes here, it grabs these two and substitutes them in. So if I run it, it runs fine. It did all that logic at compile time behind the scene to import the correct functions in the right place.